Dear children, today in today's session, exercise number 9, question number 5. We will start with question number 5. In this figure, ABCD is a quadrilateral. If you observe the figure, ABCD is a quadrilateral, four-sided figure, in which AD and BC are equal. PQRS are the midpoints of AB, BD, and AC and CD, etc. Prove that PQRS is a rhombus. That means all the sides are equal. All the sides are equal. So now one by one we can take to prove PQRS is a rhombus. Prove PQRS is a rhombus. Now I will take the first triangle ABC. Proof. In triangle ABC, if you observe ABC, PS is parallel to BC. PS is parallel to BC. PS is parallel to BC. Therefore, PS is equal to half of BC. Equation number 1. Correct? Now I will take the triangle ABD. In triangle ABD, I am applying the midpoint theorem here. In triangle ABD, if you observe in triangle ABD, PQ is parallel to AD. PQ is parallel to AD. This implies PQ is equal to half of AD. Equation number 2. Now I will consider the third triangle. In triangle BCD. So which are the parallels here in triangle BCD? If you say RQ is parallel to BC, or QR is parallel to BC. This implies QR is equal to half of BC. Equation number 3. Correct? Now I will triangle ACD. In triangle ACD, SR is parallel to AD. SR is parallel to AD. This implies SR is equal to half of AD. Equation number 4. If you observe from equation number 1, 2, 3, 4, what you observe? RHS are equal. Why RHS are equal? Because they told already in the question AD is equal to BC. See, observe here AD, BC. That means they are equal. So this implies PS is equal to PQ and PQ is equal to QR and QR is equal to SR. Therefore, we can say PQRS is a rhombus. All the sides are equal. Okay. So this is the answer for the question number 5. So in this bracket you can write because AD is equal to BC. So note down this sum. So in question number 6, if you observe in the textbook, ABCD is a parallelogram. E is the midpoint of DC and F is a point on AC such that F is a point on AC such that FC is equal to, or that means this CF is equal to 1 by 4th of AC. It is 1 by 4th of AC, 25% of AC, correct? What we have to prove is G is also midpoint of BC. G is also midpoint of BC. Okay. Now see, observe here, given CF is equal to 1 by 4th of AC. Okay? In parallelogram, diagonals. So this we have to construct a diagonal BD. Diagonals bisect each other. That means this implies AO is equal to OC and BO is equal to OD. So AO is equal to OC. They are saying that CF is 1 by 4th of OC, means definitely F is the midpoint of OC. This implies F is midpoint of OC. Correct? F is midpoint of OC. So now in triangle DOC. In triangle DOC, EF is parallel to OD. EF is parallel to OD. Why I am saying that they are parallel? Because a line drawn from the midpoint of one side of a triangle is parallel to the other side and bisects the third side. That means it is bisecting. Now F is midpoint of OC now. So therefore we can say EF is parallel to OD or BD. So it is EF is parallel to OD or BD because OD is nothing but a part of the diagonal BD. So OD is part of the diagonal BD. Therefore it may be parallel to OD or we can say it is parallel to BD also. By converse of second theorem, a line drawn, therefore in triangle CBD, therefore EG is parallel to BD. So this implies EG is parallel to BD means this implies G is midpoint of BC by using converse, because a line drawn from the midpoint of one side of a triangle is parallel to other side, and also bisects the third side. Therefore, definitely G becomes the midpoint of BC. So what we did now, they are given CF is 1 by 4th of AC. Okay, but we know that in parallelogram, diagonals bisect each other. So therefore, AO is equal to OC, BO is equal to OD. Correct? So therefore, what happens? By this we can say F is definitely midpoint of OC because F is, they are saying 1 by 4 means 1 by 4 plus 1 by 4 is nothing but a half. Therefore, F becomes the half of OC. So therefore, in triangle DOC, if you take EF is parallel to DO, they are saying. If EF is parallel to DO, definitely EF is also parallel to BD also. So in triangle CBD, if EF is extended here, that's all. So therefore EG also it becomes parallel to BD. By converse of midpoint theorem, we can say G is also midpoint of BC. Note down this sum. So in question number 7, ABCD is a kite. So here two pairs of adjacent sides are equal. AB is equal to AD, BC is equal to CD, and the diagonals they intersect at right angles. They are diagonals, they intersect at right angles. Okay. Now AB and AD are equal, they are given. CB is equal to CD. EFG are midpoints of AB, AD, and CD respectively. So prove that angle EFG is equal to 90 degree, and if GH is parallel to FE, then H also bisects CB. That means H is the midpoint of CB. We have to find out. First, we will consider the first one. So first proof. First one. I will take the triangle ABD. In triangle ABD, E and F are midpoints of AB and AD. That means this implies EF is parallel to BD. EF is parallel to BD. Correct? Similarly, we can say, F and G are midpoints of AD and BC. Midpoints of AD and BC. So this implies FG is parallel to AC. In kite diagonals bisect each other at right angles. So this implies, since these EF and FG are parallel to BD and AC, and the diagonals BD and AC are perpendicular to each other, definitely we can say EF is also perpendicular to FG. So this implies EF is perpendicular to FG. This implies angle EFG is equal to 90 degrees. So how we can prove this angle EFG is equal to 90 degrees? Since that the EF and FG are parallel to the diagonals BD and AC of kite, and the diagonals AC and BD are perpendicular to each other. Therefore, we can say that EF is also perpendicular to FG. That means angle EFG is always 90 degrees. So note down this sum. I will move on to the second one. So now in the second part, GH is parallel to FE. There we go. GH is parallel to FE. Then H also bisects BC. When you observe this question, converse of midpoint theorem should come into your mind. What it says? If a line drawn from the midpoint of one side of a triangle is parallel to the other side and bisects the third side. So already we proved EF is parallel to BD. Definitely GH is also parallel to BD. So therefore we can say, so since GH is parallel to EF and EF is parallel to BD, therefore GH also parallel to BD. So therefore GH is parallel to BD means definitely H is bisecting BC using converse theorem. So in triangle BCD, GH is parallel to BD. Why? They have told GH is parallel to FE, GH is parallel to FE, and FE is parallel to BD. Proved. Correct? GH is parallel to BD. By converse of midpoint theorem, MP theorem, midpoint theorem, what it says? By converse of midpoint theorem, I am not writing the definition, you know already the definition. A line drawn from the midpoint of one side of a triangle is parallel to the other side and bisects the third side. So therefore, by converse of midpoint theorem, we can say H bisects, H is midpoint of BC. This implies H bisects BC. H bisects BC. So note down this sum. So question number 8, ABCD is a parallelogram and E is the midpoint of DC and AB is parallel to DG. What you have to prove is AD is equal to half of GC. Okay. Second, DG is equal to 2 times of AB. First we will prove first one. In order to prove this, I will take the triangle CDG. In triangle CDG. In triangle CDG, E is midpoint of what? E is midpoint of DC, EB is parallel to DG. By converse, what we can say? By converse of midpoint theorem, B is midpoint of CG. So this implies BC is equal to half of CG. Correct? BC is equal to half of CG. But BC is equal to AD. Opposite sides of parallelogram ABCD. Correct? Opposite sides of parallelogram ABCD. This implies instead of BC we can write AD is equal to half of GC. This is the first proof. No. First proof. So if you come to the second part of the question, we have to prove DG is equal to 2 times of EB. So we know that EB is parallel to DG means, so in triangle CDG, EB is parallel to DG. This implies by midpoint theorem, EB is equal to half of DG. Correct? EB is equal to half of DG. Now you cross multiply. So what happens? Therefore, DG is equal to 2 times of EB. DG is equal to 2 times of EB. So note down is the sum. So I will end up the session for today. So in the next session, I will continue with question number 9. Question number 9. Okay? Thanks.